Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the last tutorial, I started off my password cracking series with an introduction on the principles and techniques involved in the art of cracking passwords. In the previous tutorial, I showed some specific tools and techniques for cracking Windows, online, Wi-Fi, Linux and even SMP passwords. And this series is intended to help you improve your skills in each of these areas and expand into some untouched areas. Very often hackers new to password cracking are looking for a single tool or technique to crack passwords, but unfortunately in reality that does not exist. Like they show in the movies that you cannot just go ahead and type something 2-3 line of code and you can hack. That's not possible in the real world. But that's fortunate for network security though. Each type of password requires a unique strategy tailored to that specific situation. The situation can be the type of encryption such as MD5, SHA-1, NTLM, etc. Remote versus offline, salted or unsalted, and so on. Your password crack strategy must be specific to that situation. So in this tutorial, I want to discuss about the extreme password cracking strategies. Many new password crackers simply run their password cracking tool and expect a breakthrough, but that does not happen. They will run a huge word list and hope for the best. If it doesn't crack the password, they're lost. They will think that maybe they will just leave their hope completely. Here I want to develop a multi-iteration strategy for password cracking that will work on the vast majority of passwords, though not all. No strategy will work on all passwords with the exception of the CPU and time-intensive brute force cracking. So let me tell you something about how we could go ahead and develop password cracking strategy. I will assume here that we are after more than a single password. Generally, password cracking is an exercise of first capturing the hashes. In Windows system, these are in the SAM on the local Unix files, and then we have the other one, the etc, shadow, and Linux. Let's say, for example, Linux and Unix use MD5 and modern Windows use HMAC MD5. Other systems may use SHA-1, MD4, NTLM, etc. Make certain you know what hash is being used on the system you are trying to crack. Otherwise, you will spend hours or days without having satisfactory results. All that being said, John the Ripper has an automatic hash detector that is correct almost 90% of the time, but when it is wrong, there is no way to know. In Cain and Abel as well as the Hashcat, I must tell the tool what type of hash we are cracking or we are trying to crack, else it will not work. So brute force attack passwords are short passwords. Although it might seem contrary to common sense, I often start by trying to use brute force for very short passwords. Although brute force of long passwords can be very time consuming, it can be days or weeks, but very strong passwords can be brute forced in a matter of minutes. And I start by trying to use brute force or 6 characters less. Depending upon my hardware, this can usually be accomplished in a matter of minutes or hours. In many environments, this will yield at least a few passwords. In addition, I'll also try to brute force all numeric passwords at this stage. Number passwords are the easiest to crack, and 8-character numeric password only requires that we try 100 million possibilities. And even a 12-character number password only requires 1 trillion possibilities. And you may think that is huge, but with powerful hardware, we can do this barely, let's say example, without even wasting a single time. So here we have configured Cain and Abel to brute force 6-character password that are only numbers. So the first would be a low hanging fruit, to be more precise. Once I have broken a few short passwords by brute force, I'll still likely have a file that has many hashes in it. If we're trying to compromise an institutional or corporate network, we usually only need to crack a single password to begin the network compromise. Although the user whose password is cracked may have limited rights and privileges, there are many ways to escalate privileges to system admin or root. This means that if we crack a single password on a network, we can likely take down the entire network. All of the above have been said, let's next go after any low-hanging fruit. That means let's go after these passwords that are easiest to crack. For instance, if we now use the institution that has a password policy that all passwords must be 8 characters. Many people will make their passwords the absolute minimum, that is just 8 characters. To attempt a quick and dirty pass on these hashes, simply choose a list of dictionary words that are 8 characters. Running through the millions of words in such a list will generally take over approximately a few hours, and it's more likely to yield a significant portion of the passwords. Or the second point being social engineering, just try common passwords. Human beings, although we think are unique, tend to think and act similarly, but we are just like a pack of animals. We follow the herd and act similarly. The same can be said for passwords. Users want a password that fulfills their organization's minimum password policy, but it's also easy to remember. That's why you will see passwords such as admin plus 123, admin@123, root@123, or something similar to that, or password@123, or hash, or one or two letters may change. So despite its obvious simplicity, it fulfills a password policy of minimum of 8 characters, uppercase and lowercase letters, a special character and a number. Believe it or not, this password and its variations are used numerous times. And knowing that humans tend to use these types of passwords, in my next iteration on the password hash list, I will try a password list of commonly found passwords, and numerous sites on the web include word list of cracked or captured passwords. In addition, you might try scraping the web to capture as many passwords as possible. The step 4 would be to combine words with numbers. Running through the low-hanging fruit in the step 2 and common words to passwords like step 3, it will likely yield at least a few passwords and the time it consumes is minimal. Next, we want to attack the remaining hashes and take the next step in complexity. In this iteration, we will run the remaining hashes through a list. That's because the longer dictionary words and dictionary words with numbers are the toughest. Users, because they are forced to change passwords periodically, will often add the numbers to the beginning or the end of the passwords. Some of our password cracking tools like Hashcat and John the Ripper, they allow us to use rules to apply to word lists to combine words, append and prepend numbers, change case, etc. For hybrid attack, I usually crack 50% of the passwords in step 1 and step 4, but we have harder work ahead to crack the more intransigent passwords. These passwords will often include the special characters and combined words. This would include passwords such as, let's say for example, if I have passwords such as soccer mom, SOCC3RMOM, it will go ahead and crack that. If I want to write, let's say for next big thing, I would probably write N3XT B1GTH1NG. So these are literally strong passwords including special characters and numbers, but because they include variations of dictionary words, they're easily crackable and they're not that hard. After that, we need a password list that combines dictionary words with numbers and special characters. Fortunately, that is something that John the Ripper does automatically, but other password crackers such as Cain&Abel does not necessarily. Hashcat can be run with one of its many rule sets to combine words and special characters to your word list. In this tutorial, in the next tutorial, I'll be going ahead and using the combinator rule in Hashcat that adds uppercase characters to combine words. Finally, if all else fails, we are left with brute force to go ahead and crack the password. This can be very slow with a single CPU, but as I told you previously, 1000 CPUs can do much faster. Even when we are left with a brute force attack, we can be strategic about it. For instance, if you know that password policy is a minimum of 8 characters, try brute forcing with just 8 characters. It will save you time and likely yield some passwords. In addition, you can choose your character set. Once again, if you know that password policy is uppercase, lowercase and a number, choose only those character sets to brute force. Finally, some password crackers like Hashcat have built-in policies that can choose to attempt the brute force method. These are similar to strategies that help by shaping your attacks based on the password construction protocol followed by a company group or name. These rules can be used in other password cracking tools such as John the Ripper, and here we will be seeing a list of rules in Hashcat as well. So in the end, it is very important to be successful at password cracking that you follow a systematic strategy. No matter what tool you are using that requires multiple iterations to crack the passwords. This strategy generally works from the passwords that are easiest to crack and the most difficult to crack as well. Of course, this strategy will be it will be dependent upon the tools you are using, the word list that you use, the password policy of the victim. Although I have laid out here my strategy as to how I work, yours may be different and it may be needed to adapted or changed according to the work environment that you're working in. So, and that would be it from my end for this tutorial. In the next tutorial, I'll be actually teaching you as to how we could actually go ahead and crack these passwords, and I'll go ahead and show you how I can go ahead and actually use the Meterpreter prompt to crack my Windows password. And that's it for this tutorial.